In the previous class, we studied about spectroscopy as an introduction. Today, we are going to study about rotational spectroscopy. Rotational spectroscopy is also known as microwave spectroscopy. It involves the study of transitions between quantized rotational energy levels of gaseous molecular species induced by absorption of radiation in the microwave region in the range 1 to 100 centimeter inverse. For solids and liquids, there are no well-defined rotational levels in condensed state, and also pure rotational spectra are not obtained. The essential condition for a molecule to absorb microwave radiation of a characteristic frequency is that it must have a permanent dipole moment. This is only because such a molecule can generate an electric field during its rotation, which can then interact with the electric component of the microwave radiation. Hence, microwave spectra are shown only by molecules which possess a permanent dipole moment. Gaseous polar molecules like HCl, H2O, CO, NO, etc. shows rotational spectra, whereas non-polar ones like H2, Cl2, N2 does not show rotational spectra. Now we are going to see the various aspects of rotational spectra. For that, we consider a rigid rotator. The rotation of a diatomic molecule can be modeled as a rigid rotator. The expression for rotational energy of a rigid diatomic molecules are a rigid diatomic molecule, expression for moment of inertia, expression for rotational energy, allowed energy levels, selection rule for rotational transitions, and intensities of spectral lines. Let's go into detail. A rigid diatomic molecule, expression for moment of inertia. Consider a polar diatomic molecule rotating about an axis passing through its center of gravity C. Let m1 and m2 be the masses of the atoms concentrated at point distance r1 and r2 respectively from C. So the center of gravity is defined by m1 r1 is equal to m2 r2. This is equation 1. Let r be the equilibrium bond length so that r is equal to r1 plus r2. This is equation 2. Then consider the molecule has one in which the masses points are joined by a rigid bar of length r, so that the molecule becomes on time of rigid rotator or rigid rotor. A rigid rotator or rigid rotor means a molecule which rotates such that its internuclear bond distance do not change during rotation. That is, a molecule does not distort under the stress of rotation. In this, the figure shows the two masses m1 and m2 and the distance r1 and r2, and C, the center of gravity. The moment of inertia I of the molecule is given by I is equal to m1 r1 square plus m2 r2 square, which can be written as m1 r1 r1 plus m2 r2 r2. This is equation A. Using equation 1, we may write m2 r2 in place of m1 r1 and m1 r1 in place of m2 r2 in equation A. Thus, we can write I is equal to m2 r2 r1 plus m1 r1 r2, which is equal to r1 r2 into m2 plus m1. This is equation B. From equation 2, r2 is equal to r minus r1. We may write equation 1 as m1 r1 is equal to m2 into r minus r1. This is equation C, which is equal to m2 r minus m2 r1. Or we can write m1 r1 plus m2 r1 is equal to m2 r, or r1 is r1 into m1 plus m2 is equal to m2 r, or r1 is equal to m2 r divided by m1 plus m2. This is equation D. In the same manner, from equation 1 and 2, we can get r2 is equal to m1 r divided by m1 plus m2. Substituting equation D and C in equation A, we get I is equal to m1 into m2 r divided by m1 plus m2 the whole square plus m2 into m1 r divided by m1 plus m2 the whole square, which is equal to m1 m2 square r square divided by m1 plus m2 the whole square plus m2 m1 square r square is divided by m1 plus m2 the whole square, which is equal to m1 m2 r square divided by m1 plus m2 the whole square into m2 plus m1, which is equal to m1 m2 divided by m1 plus m2 into r square. We can write I is equal to nu r square, where nu is equal to m1 m2 divided by m1 plus m2. Nu is the reduced mass of the molecule. I is equal to nu r square is the expression for moment of inertia for a rigid rotator. The remaining part of rotational spectroscopy will upload in this channel. Please check, and also if you like this video, do like, share and subscribe. Thank you for watching.